Yeah, that's it. Thank you all. Martin, the virtual stage is yours.
Okay, thank you. So I hope you can see both my screen and my presentation.
Yes, we can see it.
Perfect. So then, hi everyone to my presentation about source generators. I'm Martin. I work at Tietoevry in Austria, so I'm based in Vienna, actually close to Munich, but of course we're still remote, and I'm happy to be attending remotely at your event. And today I would like to give you a few overviews about source generators, how they work, some built-in generators that you can already use in .NET 6. It's also something new in .NET 7. And then I would like to implement a custom source generator with you. So show you what to do if you wanted to implement some custom one. It's something that I have did a bit ago, some time ago to help with writing tests. And we will also have a look in what changed in the new version of Roslyn that's in Visual Studio 2022, and some tips and tricks on what to do when you actually want to ship a source generator. So the motivation to that is, yeah, we always like to do meta programming and avoid writing boilerplate code. So when it comes to things, certain aspects that we want to add, we're always looking for tools that do that for us. So if you want to have some logging, timing, deadlock detection stuff, there are tools out there that help with that, so that we can save some time writing boilerplate code. Also, there's always this topic of serialization, whether it is to and from disk data formats or wire formats or even databases. That's just something that we don't really like to do ourselves. So if you have a framework that can do it, we can let it do it for us. Some of that generates code. Some of that only does things at runtime by looking at the structure of the code that we wrote. And I think one of the more common ones are usually when you have some interfaces that have some kind of schema, that we actually have the schema and want to generate client code or server code for that schema. So, for example, if we have Open API specification, so REST APIs that deliver that specification for us, we can generate a client or a server, and the same also for gRPC services that use protobuf behind the scenes. In .NET, there are a few ways of doing metaprogramming. I think the one that we've probably all done at some point is using reflection. So we can use reflection to look at the code and also use reflection to maybe instantiate some new functions. So for example, or new instances. So using reflection and then instantiating new objects, for example, could be a very simple way of doing dependency injection. So that is already some form of metaprogramming. If we want to do something a bit more advanced at runtime, we can use IL generator, which generates the low-level code that the runtime understands at runtime. That is very hard to do correctly, and it's a pain to debug, but it works and it makes the things that we used to do with just reflection a lot faster. But it is a bit problematic for ahead-of-time compilation. So it is problematic to do on things like iOS, where you want to basically pre-compile all the code, ship it as a binary that is signed, because Apple still does not allow run just-in-time compilation on iOS. So if you ship something like that, it will be interpreted. And if you wanted to do that for a hot code path, that might actually slow it down a lot more. But then there are also the ways of doing custom build steps in your program, in your project. So we have MS Build and we can just hook into it. And there are some actually built-in features of .NET. I think my camera might have just dropped out. There are some built-in tools. So in .NET Framework, there has been these generate serialization assemblies checkbox in the project properties that have been there for over a decade, which actually generates the XML serialization DLLs for you. So previously, when you used XML Serializer, it would generate a assembly in memory at runtime the first time you use XML Serializer on a type. But if you want to save that startup time, and actually there have been some deadlocking issues, I believe, you can do that during your build. Also, ASP.NET Core precompiles razor views, so the things that render your HTML code. And in .NET 6, they actually changed that, which I will show you later. And there are other tools that do code generation as well. There's protobuf tools and also some tools that maybe replace the actual compiler to change something in the compiler, which is something very interesting that Gail will also talk about afterwards. And there are IL weaving tools, basically tools that process the build assembly after it has been built, so it messes in the actual output that you generated. Those kind of tools are actually also very hard to maintain because there are just a lot of things that you need to do correctly, especially if you want to preserve the ability to do, for example, debugging and proper profiling. So when you're using these projects, especially Fodi, for example, also changed the license to, yeah, we will only look at pull requests or issues if you are if you contribute financially to the project, because everything that comes up is just very time consuming. So these tools are worth their money. But in C#9, so that's also some time ago, now we're in the previous of C#11, but back then we got a new feature or a new way to do things, which is source generators. So that is actually a feature in the compiler that allows us to add code to the compilation while the compiler is compiling our code. But that's also the limitation, we can only add code. So we can't really replace things, but everything that uses things like partial, we can actually add to. So if you need something that rewrites existing implementations, maybe IL weaving is still better for that. So maybe things like I notify property changed. Maybe still IL weaving is quite good here, depending, of course, on your structure and what you try to accomplish. But again, it works directly in the compiler, so you don't need to tinker with your project files. There's no custom MS build logic needed for most scenarios. And also MS build logic is something that is very hard to write, extremely hard to debug. And there are always a few corner cases that you don't really deal with. For example, you can always mess up incremental compilations or Visual Studio build times with some minor mistakes quite easily. The way this works is the compiler actually already has a plugin infrastructure for things like analyzers, where we have NuGet packages or other code that can look at the source code and emit diagnostics. So if you use things like style cop analyzers or D.NET analyzers that give you additional warnings or fixes for things like formatting or obsolete APIs, it's same plugin infrastructure, kind of, is also used to execute generators. So during the compilation pipeline of the compiler, it will stop, ask your plugin, hey, that's the current state of the compilation. Do you want to add anything? And it gives all analyzers a chance to add code to it. And if you have multiple generators, they will all see the same input. So you can't really have generators that add to code that was output by another generator. So you can't really have a generator that generates some classes that then maybe you want to have a serialization generator to generate the serialization logic for that. That currently does not work. There are some proposals to fix that, but that is actually very hard to do correctly because there are a lot of corner cases that are just hard to solve. And once you've opened that box of Pandora, it's quite impossible to close. But it's already a very, very helpful feature. If you do want to look into that, there are a few interesting links that I've posted here. Go and visit them. The cookbook basically walks you through everything that you need to know to write a generator, and also contains some hints on the links if you need some reference implementations. And of course, the last two ones, if you need any inspiration of what you could use in your project, or if you're writing a generator and want to look at how do other generators solve some problems, look at some examples that the community has already implemented. But there are already source generators built into .NET 6. So in the wave of .NET 5, where we got C#9, we got a feature for generators. And then the next version of .NET already shipped with some built-in generators. And I want to look at some of them with you now. So let's switch that. So the first thing that I want to show is actually about Json serialization. So I've got a very simple JSON file here. There's 2 entries about people. We have a person class that can be used to serialize that. And then we're using the system text Json Serializer to use the derealization and serialization function. So we deserialize the list and serialize it again. Okay, that works. And the way this works behind the scene is that the JSON framework will actually do some reflection to look at this class, look at, okay, what properties are there, what types are they, generate some metadata, and then also generate some code that will read and write these properties. But there are more performant ways to do that if we knew everything about the type beforehand and generate the code that actually does the serialization, for example, or it contains the metadata that we want to know about the person. And the way this can be done in .NET 6 is using the Json Serializer context. So you create a partial class that derives from this context. You add a JSON serializable attribute of the type or types that you want to serialize. And then the framework will actually generate some implementations. And in Visual Studio, you can actually see that. So if I open the dependencies, I can actually see the analyzers. And then there is this system text JSON source generation analyzer. So basically, it's the compiler plugin. And then this will show me the code that is actually generated and added to the project. So for example, I can see there is a person in here. And then there are a few things in here. And so some interesting things in here. Again, I'm not going to go through all these kind of internal structures, but you can have a look. So it has these property infos that it generates. So it already had a look at the person and it knows, okay, there is a first name property that has some kind of type. So it knows it's a string. It already looked at that. And it also generates a getter and setter method. So no reflection usage for accessing properties or any casting of objects around. It just has a perfectly typed method, in this instance, a static lambda that it can just call into to get values and just access the property as if we would have written the C# code ourselves, but in this case, the generator wrote it. So we got all the things that it would do at runtime with reflection we already did during compile time. And for serializing, there's already a function in here that can do serialization. So this really knows how to serialize that person. So it knows if it's null, write a null value, or write start object, write string with all the properties that it already knows about, and write end object. So we could directly write to an UTF-8 JSON writer without any reflection usage or any need to emit this kind of code at runtime. So the way we would then use this is we can actually use a new overload on the deserialize method. So we can use our person JSON context, use the default instance, and say this is an iList person. And then we can also omit this type annotation here. And now it uses the pre-generated serialization logic. For serializing again, we can basically do the same thing. When we call Json serialize, we can tell it, hey, use these things that you generated in this context. And it would write the values out. Let's have a look if that still works. Yes, it still works. Then there are a few customization options as well. So there is a generation mode, and we can then tell it, yeah, there's some serialization stuff that I really want to do custom. So if you configure some advanced features of the serialization framework, you could switch out some ways of serializing stuff that is would maybe write some things out differently. Then you can tell it, hey, please only generate the metadata so you know which properties are in there. Or you can just say, okay, generate the serialization stuff, but you know, there's some metadata stuff I'd like to tinker with at runtime, so don't prepare that. So you could opt into these features that you really want, so you can actually combine them using the OR operator. The default is just generate both, and I guess in 90% of cases where you don't do any fancy advanced stuff, this should work fine. So that's it, what I wanted to show you for the Json serialization. Then let's go on to web applications. So in ASP.NET, we got these fancy Razor pages, so CS.HTML. And previously, those have been first compiled at runtime. Then we got ASP.NET Core Razor pre-compilation that would generate a second DLL next to a project. And now in .NET 6, we finally got a built-in source generator that actually generates C# code out of these Razor files. And I'm actually going to show you a different ways of looking at that. So maybe you're not using Visual Studio, but maybe Visual Studio Code. Of course, this also works cross-platform, where we don't have these tree views. You can tap into the things that are run in the compiler, but you can also do something in the project files itself. So there's this feature that you can turn on that's called Emit compiler generated files. So it will tell the compiler, hey, if you generate anything during the compilation, please also write it to disk. So it would put it in the object folder. We can also customize that output path using the compiler generated files output path. So if we compile this, we could have a look at generated, and then we would see the directory Microsoft Net SDK Razor source generators and so on. And we can actually have a look. So these are the pages. We could look at the layout, CS.HTML, and this would then contain all the code that the Razor engine created as C# code. And that is hosted by the source generator and just added to the project. So this already parsed our CS.HTML file. It already contains all these things that are distributed throughout our Razor files, contains all the write literal, header, nav, etc. The same for the index page. We would have the write literals and so on with the custom code. I'm not sure if there's a custom code in here, but it would have that in there as well. And it already contains these references to where all of these lines come from, which are used for the debugger in this case. So that basically streamlines the integration of Razor into the compilation a bit. And there is another feature that I wanted to show you in this case, in the logging space. So if you're using the Microsoft Extensions logging abstraction in our project, which is something that I'm actually have. One of the things that I'm most excited about in the .NET Core wave is that we finally got an abstraction over logging that we can just plug all of our logging frameworks into. So when we want to actually change logging implementations, that is now a lot easier, and also it's a lot easier to write libraries. But these loggers are also quite tricky to use efficiently. So if you want to have very efficient logging, we would have to do these calls like logger try, hey, are we actually running in a specific log level to maybe not do some string interpolation or not serializing stuff. And we also have the string interpolation, which is a bit weird because that's not really a string format where you have 0, 1. This is actually a structured logging information that a structured logging backend could pull out the actual values and the structure of the log messages, including these names as some metadata. And so there is something that we can use. We could use predefined logging messages, and those are a bit tedious to maintain, but we can use a generator to generate that for us. So as long as things are partial, I can put a partial void method in here, annotated with logger message, and I can tell it, hey, this should call the logger and log this message with this template, this level. I can put even more information in here and these parameters, and it will match the parameters to the actual message. So I could replace that car and then have a look at what the generator generates. So there's now the extensions logging generators, logger message, and that generates this calls to logger message.define. So the logging framework does not need to parse the template anymore. It only has to do that once. And it already has all of the options set in here as well. And then, of course, it generates these is-enabled call and then does the actual logging. And actually, if we change something, so maybe if we want to have last name here and first name there, then the order is a bit different in the message, and the implementation then switches to use a structure that actually captures these values, has a toString in here to serialize that structure. So it has a custom formatter, and then generates these log call for us. So these should be the way that uses the least overhead, or that you can get the most performance out of when logging. So from all of that. And by the way, this looks if there are any iloggers or iloggers of T in the current class. So if you only have one, that should pick the correct one. But you can also do it in a separate class. For example, if you want to use extensions on ilogger, you can do that as well. So in this case, I want to log method enters. So I can call that in here as well. I can call logger log method enter. And of course, it would then use the generated code to make sure that that has the least amount of overhead possible. And of course, I can also specify event IDs and some more options. So the custom event names, event IDs, which are pretty tedious to define ourselves, you can just add in here, especially if you have a place where you can collect all of them in once. That's a very good way to manage your event IDs. What I've used this before is for logging things in a mediator pipeline. So when we send basically events and messages in our applications, this is something where I'd like to turn on trace logging on and off to investigate, and this actually helps a lot and doesn't add too much overhead per se. And then there is something new in .NET 7. So in .NET 7, we finally got regex generators. So we can have a partial method that gives a regex, and we can tell it, yeah, please generate that regular expression from some specification. So it does the parsing and emitting of the state machine during compilation. So we can run them without doing any or without having fewer overheads during runtime. Actually, I have not yet looked at the code that generates. Maybe let's have a look together. So that is the textual expression of what I've just written. And then there is the actual implementation. So something I would not want to write myself, but now that it is in here, go-tos, now that it's in here, it can be optimized by the compiler as if it was C# code, and it can be perfectly precompiled into native code using ahead of time compilation without doing anything fancy during runtime. So that's it for the demos. Again, we've had a look at the system.text JSON source generator. There's also this comparison of which features you get by enabling one of the two options for generating codes. So these generation modes, depending on which features you need, you should maybe choose one or the other, or you can use both. In my situations, I've just used the default and I've had no problems with that. In some benchmarks, there is a drastic increase in performance. So there's this caching benchmarks, which relies very, very heavily on Json serialization. And that has a 40% increase. So it's quite substantial. Of course, this would not be fun if we couldn't use it in our APIs. So both for ASP.NET APIs, you can tell it, hey, use that context for serializing out our responses. And we can also use it on the HTTP client, so that when we call a foreign API, we can also use these features. Then the Razor source generator is on by default. There's also a way to opt out if someone has problems. Worked for me, but they're still good to know that there is an escape hatch to fall back to the logic that we had in .NET 5 and previously. Then the logging source generator, quite easy to use, finds your logging instance and emits these calls. And in .NET 7, we now got these regex generator. But it would not only be half the fun if we couldn't write our own generators, so we can actually do that. And I want to show you this in a short demo. So here we are. So I think one of the most used examples for source generation is I notify property changed. So whenever we write any view models for MVVM patterns, we would have to implement this interface that tells the thing that is using our models if something has changed about our model. And that is very tedious code that we don't really want to write ourselves. And there are countless numbers of ways how to do that. I'm going to add number n+1. In this case, what I want to do is I want to have an interface that defines how my models should look like. And I want to actually have a concrete implementation that implements that interface. And I want to not bother writing an implementation of I notify property changed myself. So I just want to have something that implements it for me. I want to have something like an auto notify attribute that does not yet exist to generate that implementation. And what I want to have from it is I want that this model has these concrete properties that don't exist yet. And I wanted to have a property changed event that I can register to catch any changes in the object itself. So that doesn't compile at all. But what I can do is I can create a project that is a .NET Standard project, in that case .NET Standard 2.0. Sadly, we can't really go any higher because the limitation is we need to run as a plugin to Roslyn. And in Visual Studio, Roslyn is hosted on .NET Framework, so we still have to support .NET Framework. So the highest version of .NET Standard that we can use is 2.0. Maybe something changes in future versions of Visual Studio, but currently that is what we need. If we run in the CLI tools, so .NET Run, or in VS Code with the feature of using the SDK, I think now it's still opt-in. It should be the default in a couple of months. This will also run on .NET Core, and of course, if we run on Linux and Mac, we would also run on .NET Core, but in Visual Studio, .NET Framework it is. And then we can just reference Microsoft's code analysis packages. So there's the code analysis C# package and the code analysis analysis package. that we can reference and get all the interfaces and helpers that we need to implement a source generator. And the way we do that is we implement an iSource generator interface and tell the compiler, hey, this class is something that I would like to use as a generator for C#. We can also use a different language in here, but for now, let's stick to C#. And how do we test it? Well, we could use that as a generator in a target project. That doesn't work that well within Visual Studio because it might have problems reloading or assembly every time. And this also makes it very hard to debug. So my go-to recommendation is use tests. The way I do this is I use the Verify framework. So it's a project that does some kind of example-based testing or verification testing. So I have to verify everything that changes in the implementation or the output of running a test. I will show you that during the implementation of it. And this already has a feature for source generators. So I can actually initialize the source generator implementation, and then I can write tests where I create a C# compilation, run my generator instance using a C# generator driver. That is everything until here is given to me by NuGet packages from Roslyn. The same for the run generators. I can run these generators on the compilation, and then I can use this Verify framework to actually have a look at the state of everything and tell me if something changed from the last time this ran. So the first time this runs, it actually does nothing, but I can already set breakpoints and run the tests, so I can actually do some debugging. But if something changes, it will compare the changes to the thing that I've previously accepted and ask me, hey, is that what I wanted to do? So I will show you the changes later on. But for now, these are the tests that are run. So it actually tries to compile this code using references to our generator. So there's also a test in here that just tests, hey, run this generator, try to compile it into a DLL and see if that works. And when I run that, since the generator is empty, that test should fail. So we have failed tests in here. Yep, couldn't compile anything. But now we have something to go from. So let's have a look at this class. So we want to implement that generator. So the first thing that we want to do is have a look at these methods. So there are two methods in here. One is in an initialize method. That is when the compiler asks us, hey, set up everything you need. And then execute is where it actually gives us the current state of the compilation and asks us, hey, now is your chance to contribute something to the compilation. But we can do something interesting or contribute something in the initialize function already, which is we can actually add the attribute. So there are different ways of how to actually make that attribute available in the target code. One of them would be adding another DLL file or a reference that contains this attribute, but we can also generate source code that contains this attribute. And we can also mark it as conditional for the compiler to tell it, yeah, we don't really need that in the generated DLL. So remove it unless we are setting some interesting compiler-defined variables to debug that code, but otherwise this would not affect the compiled output. So we can use this source text. Again, that's a feature of the Roslyn framework that has existed for a while. We have to give it a name, and then it should be available already. The interesting stuff, however, is looking at the actual code. So I want to actually, in the execute method, what do I want to do? I want to look for things that we need to generate. So basically doing what reflection would do at runtime, and then generating the code for it and adding this code to the project that we're compiling. So first of all, I'll add a structure to help us keep track of things. So I have this implementation to generate, which is just a data class that holds the things that we are interested in. I'll come to the types later on. And then the interesting thing that actually helps us look at the source code and do that reflection is a syntax receiver. And so compilers are usually built around syntax trees or some similar data models that are have some kind of tree structure. And while we could use some link-like structures to do like for each file that we want to compile, for each namespace that is in there, or for each class that is in there, we can actually use the visitor pattern, because a lot of compiler things are based on a visitor pattern. When I tell it, hey, I'm interested in that thing, call me whenever you see something like XY, or call me on everything and I'll tell you if I'm interested or not, or I'll do something if I want to or not. And in Roslyn, that is called a syntax receiver. So this, I can register the syntax receiver in the initialize method. I can tell it, hey, I'm interested in syntax stuff. Tell me whenever you see syntax. And then it will tell me whenever it will iterate through all of the user's code and call this onVisit syntax node callback for every node of syntax that it has. So we can decide if we want to do something with that or not. And behind the scenes, it uses the internally the fastest way to navigate through the data structures, which if you would do something like link or even for each statements, we would have some overhead for very large pieces of code. And what we can do in here is we actually can look at the syntax code and what actually is syntax. So there's something that helps in here. So there is sharplab.io, which actually helps us decompiling code. In this case, this code doesn't compile, so we can't really decompile it, but it can give us a look at the syntax tree. So we can expect which data models we will see. So the first element of the tree is the compilation unit, which is basically the file itself. And then we can have a look at what is in that file. So things like using directives, global statements, interface declarations, class declarations. So we could say we're interested in class declarations. And it doesn't matter to us if the class declarations are inside of a namespace, inside of another class declaration. We can just tell the compiler, yeah, give me all the nodes that you have, and then filter for what we need. So we are interested in class declarations. And we will have a look at these attribute lists and the actual attributes in here. But again, in here, we see that only has things like identifier, so it knows the name, or it knows that there is a type of expression and with an identifier name. But it doesn't really tell me anything about what person view model or what it actually means, because syntax really is about the characters that are in here and what they mean in the C# syntax definition. It doesn't give me semantic understanding of the code. So it knows that person view model is an interface, and from that I could query which properties are defined on that interface. That is actually a semantic model. So in Roslyn, there's always things that has syntax, which has tokens and nodes, and then a semantic model that basically has these kind of symbols. So I'm now, where are we? Yeah, I can get the node that we're currently visiting. So this is a syntax node, and see, okay, we are interested in class relations and only these that actually have attributes. And then we can switch from the syntactic context to the semantic context. So we can ask the semantic model, okay, for this syntax that I'm seeing, please give me the semantic model. And then we switch from syntax and tokens to symbols. And in that case, we expect named type symbols. So we know it's a type. We check if that actually returns something that we're interested in. And then we can actually have a look at some more semantically interesting things about that type. So we can ask this, okay, what attributes do you have? And now if it only sees auto notify in the syntactic model, in the semantic model, it can actually give me the whole information about what the actual full type name is meant by typing that code. And we can see, okay, does it already contain all the information that we need? Is everything set? And then I can actually get the type that is referenced in the first constructor argument. And then I can preserve these things in my list of implementations that I need to generate. So basically the type, the class that we want to generate for, and the interfaces that we need to implement. We keep track of that. And then for these, I can write a generate implementation method. So given one of these things that we found, I can create a string builder and generate C# code. I always start with auto-generated so that any code that I now emit doesn't raise any issues when it doesn't match the end user's code style settings for like indentation and whatnot. I can also have to keep track of, does the target project use nullable reference types or not? So maybe I need to also account for that. Can maybe also have a look, do we need to use a namespace in here, and everything else. And then I can write a partial class, implement iNotify property changed. In this case, I'm also not emitting any using statements, so I have to always use a fully qualified type name. Create this event. Then I also upgraded the sample to actually have a somewhat sensible implementation. So I also generate this onProperty changed protected void method that just invokes this event. And then I can iterate through all the interfaces that I need to implement and through all the members of these interfaces, get this property symbol, so the semantic information about a property out of that. Do some logic for nullable reference types to check, do we need anything special for that? And implement the getter and setter. And also emit a backing field. So we should now have a string that contains the implementation. Now I need to wire it up. And the way I'm doing that is in the execute method, I try to get any options that I need from the compilation. So for example, am I using nullable reference types or not? And I can also get back the receiver, the syntax receiver that I registered, pass it to my own type because I know what I registered, get the implementations that we need to generate. So everything that we found basically in this not reflection, and generate the implementation for all of them and add these as a source with the type name .g.cs. And from that, it should actually compile. So if I have done that correctly, yep, we are passing the tests. My main application still does not compile because I have not yet used the generators. And the way I'm doing that is I will add a project reference to not the tests, but the actual implementation. Perfect. But that is not a normal reference. I need to do a few special things in here. One of them is this is not something that I really depend on for any output. So this does not add to the dependency graph or the NuGet package graph of the things that I want to build. So this is only used as a reference, hey, this needs to be built before my project, but I'm not referencing any assemblies in there. So this .NET Standard 2.0, if that was incompatible with something that I want to publish, that would not cause an issue now. And I want to use the outputs that this project generates as an analyzer. So basically these compiler plugins. And now, ideally, my code should compile. I should see the code that is generated. So we have this attribute that is generated and the view model implementation that is generated. And now my code should compile and ideally, yep, run. So we get these change notifications. What I wanted to show you about the tests is whenever so of course I pre-created these tests and then removed the implementation. Now my tests are running again. But when I now change something about my implementation, maybe I want to use expression-bodied members now. Right. This should still compile. Maybe Visual Studio has got that update now, maybe not. But if I run the tests now, maybe not debug. No, this now tells me, yeah, I've failed the test. This should have given me an output, but it tells me, okay, I failed the test because something changed about the expected state. So I can have a look, okay, this is what I changed. Yeah, that looks legit, still compiles. And what it did for us, it copied a command into my clipboard that allows me to accept these changes. If you're not using Windows and Visual Studio, you will see this in the output of .NET Test. And what it does is I actually update. Okay, it opened that diff in a different Visual Studio instance. Thank you very much. I did not need that. Perfect. So what it actually does is it keeps track of the expected state that in separate files, so .verified.cs, I would commit that into source control. And whenever I want to accept a change that I made in the test, I would change this file, which contains the expected output. So now that I have updated that file and manually accepted the change, I can just run the tests again. Yep. And it will pass again. So these are very useful to check, even if you do some refactoring in the implementation of generators or any other piece of hard-to-test code that you write. You can still see, okay, do I still generate the same output as before? Or if not, what has changed? And gives me an option to review of what I've actually changed in the output. So that's a very helpful way to test things. So let's quickly jump to a different implementation of actually the same generator. So what I've shown you before works in both Visual Studio 2019 and Visual Studio 2022, both in Roslyn 3 and Roslyn 4. But now in .NET 6, since that requires Visual Studio 2022, more and more people are switching to that. And Visual Studio 2022 and the current version of Roslyn actually has a new feature for generators that's called Incremental Generators. So as we've seen before, we always had this step where, okay, here's the compilation, do your logic, and we would always execute all our logic. So if we were fancy, we could cache something or implement caching at some point, but that's very tedious to do, especially to do correctly with all of the Roslyn data structures. And Roslyn actually now has a new way of doing that works in Visual Studio 2022. And also if you're using all of the built-in generators in .NET 6, they work using that approach. Also the NuGet packages that also work outside of .NET 6. So for example, the Microsoft extensions logging, which I think can still run on .NET Framework and .NET Standard 2.1, I think, or even 2.0. That actually switches, okay, with some MS Build logic, switches between the analyzers that are used in 2019 or 2022, or depending on what kind of host you're using to compile. But in the new Well, this is now an incremental generators. The ways of thinking about the code are still the same. The difference is this new interface only has one method. So it gives me a context. And the way I use that is still a bit similar. I have this register of post-initialization where I can add my attribute. But then anything that's on here are providers. So there's a compilation provider, a syntax provider. And the way this is built is very, very similar to link. So for example, I can have a select statement in here that from a compilation gives me the thing that I am interested in. So for example, I want to know, are we using nullable reference types or not? And what I get back is an incremental value provider. And you can think of this similar as an async stream, or maybe an IEnumerable that gives me updates about anything that changes in the project. And then I can also have a syntax provider that gives me the current status of the syntax, and I can write transformers from that. So basically, this is something that we would do similar to a link select, and then I can have a where. I can combine it with the other things that I'm interested in, then use a select again, but these are not the ones from link. These are from Microsoft Code Analysis and work on incremental values provider. And for custom things, for example, in the implementations to generate, I can also, okay, maybe I didn't do it here. I can also use equality comparisons and equality comparers to give hints to did something change or not. So the way this works is this generates a graph of things that need to be done with the code. And whenever something changes in that graphs, Roslyn can actually determine which things it needs to call and which not. So for example, if only one class declaration syntax changes, so for example, this maybe creates 10 implementations or 10 things that we need to generate. And we would generate 10 implementation files. If only one of that changes, we would still run this code, but then it will say, okay, comparing to the last time we've run that code, only one thing changed. So we will only execute the code paths that this one change affects. So we could save some time during compilation. But the basic concepts are still the same. So we still have our generate implementation functions. We still have the thing that we need to keep track of. Only the same code for testing what we need to generate for. That's still the same code, just reordered a bit, and it looks a bit more like Link. And that is what's new in Visual Studio 2022. But there's also some more things you can use. I will just quickly go over that. So you can also look not only at source code, but only at other files. So for example, if you're using schema JSONs, we can set the build action from it. It would be none or content. We can set it to C# analyze additional file, or in MS build in the project file, it would be called additional files. And then we can actually see that in the generator. So we can ask in this case, the compilation context, yeah, give me the additional files, and I can filter for that interests us. I can also set metadata on that. So this additional files tag would be generated when selecting the build action, but we can also add some additional metadata. So I could define my own metadata generated models namespace, tell the compiler through this compiler visible item metadata item, yeah, I also want that to be visible to the compiler. And then I can actually have a look at that in my analyzer using these analyzer config options where I can actually read that metadata out again. I can also read public properties. So if you have any configuration options for a generator in the project file that maybe are not representative or cannot easily be represented as things like attributes, I can also do that in the project file. Also tell the compiler, hey, some properties I want to be visible to the compiler, and I can then access them from the generator. In this case, global options that will affect the compilation. And the way we could do this for shipping packages is we could also include some MS build logic in NuGet packages that we ship. There are ways to do that. And we could define these information about what should be visible in the compiler. We could define that in the NuGet package, so the upper part. And then we can put in our documentation, hey, if you're using my package, you can define this. So basically the lower part of the property group, you can define this in your project and configure my package for your need. So that could be some way of separating that. Something else you need to consider when you're actually shipping a NuGet package is do make sure that the code that you generate compiles in the version of C# that the target project uses. So again, source generators were introduced to C# 9. You can use it on projects, I think, that can target lesser versions of C#. It's quite tricky to get it working, but now that we have C# 10 and C# 11 coming around, so for example, I created a property and a backing field, but upcoming versions of C# will actually have a field keyword, so I would not really need to generate a backing property anymore. But when I add that to my generator and the target project maybe still uses C# 10, that would fail to compile. So be cautious of that. Also, do we use nullability or not? Maybe you want to create nullable annotations for projects that use it. Also, if the user does something with the attributes that are not really good to do, make sure that you emit actionable diagnostics. So warnings, hey, you're using my attribute with a type of argument, but that's not an interface, or that does not have the things that I really need. You can do that. Also make sure that the code that you emit is marked as auto-generated, so that tools that look at the code don't raise any styling issues. There are also tools that look at files on disk. So if you turn on the write the generated files to disk, so I can have a look at that. That could also trigger some code analysis tools on build servers. And of course, you may want to have some configuration options, maybe using the project properties that I just showed you in the previous slides. And also make sure if you're using, for example, the new Roslyn 4 APIs, then you make sure to document your package at, hey, that only works in .NET 6, 7, and so on. And if you actually want to ship that NuGet package, then go back to this Source Generators cookbook. It has most of the useful information that you need to or tell you what to do, so that when someone references NuGet packages, it is automatically used as an analyzer and not just added as, for example, a DLL or some code that you could call in your code, but not use as an analyzer. So just follow these instructions. So, any questions? If not, I would hand back over.
Yeah.
To John.
I mean, sometimes it takes a bit of time to calculate.
What I can also show, that is that cookbook. So again, it will tell you most of the things that you can use and what you can do and what you should put in your project file so that it will actually generate a usable NuGet package. If you want to have a look at some of the generators, there is this list of generators that have some interesting examples in this well, it grows longer every few months.
Yeah.
There's also a repository that shows you that with beautiful examples of how to use these generators. And how I actually got started with that is I had an application that was very data centric and worked with some business models. So we had a lot of business models, and then writing tests, especially for validation or some variation tests, was quite tedious. And using a data builder pattern was quite helpful. And so I created a very simple, very, very simple generator. I think it already has some bugs if you have like get only properties. That given a class or something that we would have in our entity framework model, it would generate a builder for it. So we can have a person builder filling out these properties, and we would call .build to get the actual value. But then if you wanted to write a test where something changes to the default, I could say, okay, without that optional thing, and with the changed other thing, build me that. So it could have like contract dot without address, for example, or with shipping options, whatever. So you could also write extension to that, so you can have more appropriately named test methods. So that was just used to make our test data a bit more understandable when going through tests.
I would have a question.
Yes.
Out of curiosity, you showed those incremental source generators, and of course they make everything faster. And the question is, at what point is it worth it? So how bad are the compile times without them? And what kind, probably not if you use something which, I don't know, creates 2 or 3 files, but maybe some Json generator or so. So do you have some experience at so what's the trade-off is? Because I think it's probably more effort developing an incremental source generator. And yeah, probably there is some point where you feel like, I don't know, it's Json generator, which is heavily used also, where it might be worth the effort or not. So any idea on that or any statement? I'm just curious. So it's a very generic question.
So the honest answer is I don't exactly know. What I do know is when I use large projects and I want to generate a lot of code or go through a lot of code, it will be a bit slower. It's also that the Visual Studio team is looking into executing these generators as often as possible. So we could end up in situations where after every couple of keystrokes, they would run generators and maybe prefer these generators that are incremental. But I don't have any data on how fast these things actually perform. What I do know is that
I could assume it's the same as for everything, as for every optimization, right? With profiling also, basically your code is fast enough until it gets annoying, and then you should start to look at other solutions.
Exactly. So, for example, I also have projects where we had 3 years of entity framework migrations that we put into a separate project and then made sure that no analyzers are running on that code, even the ones that are built into the .NET SDK, because that is a build difference of 30 seconds or so, because there are just millions of lines of code of entity framework migrations. So that even has problems just running the analyzers that don't even generate something. And using these diffs even on the syntax level, so it knows which nodes have changed. That can be quite a performance gain. The interesting thing is at what point these analyzers are run. So right now they are not run on every keystroke, but in the future they could be. So I guess it's just a matter of optimization. Obviously, the compiler team built the first version and then realized, okay, we need something better. And when Visual Studio 2022 shipped, there was this incremental generator feature already there, but it was not yet incremental. So it was running, but there was no caching. I think that was the first versions of that were in 17.1 and now 17.2. So we will actually see
MVP.
how much that brings. Exactly.
So if I understand you right, it's basically you kept one solution, but basically it's code where you don't want to run generators, only made a sub project, a library or so, and have this one compiled separately so that the analyzers don't, or the code generators don't run.
Exactly. So I had one situation where my project was too large. I've yet to encounter a project where my generator is too slow. However, so the first version that I tried, and I think this one still uses one that uses for loops to iterate through all the code and not use the syntax receiver. And on large project, that is already a notable difference. So it's a
okay. Thank you.
Look if it works for you and for your consumers. Of course, for first-party stuff, for example, Json generators or logging generators, so things that will basically run on nearly basically every C# project out there. Because whenever I create a new .NET project, the regular expression source generator will be running, the JSON text source generation will be running on every file in every project. So that needs to be basically as fast as possible. Same as the net analysis. So this is basically what I did earlier. I was just create a new .NET 7 project. That's what I used, and these things will be running on every .NET 7 project out there, unless they specifically disable these analyzers. So that needs to work with basically all the code bases that will be upgraded to .NET 7. So making that fast is probably a priority for the Microsoft teams themselves. I don't think you have to do it for your projects if you know there are not going to be millions of lines of code in one CS project. And you will probably not be writing code or analysis that will be added as a default to every .NET project. So it could be premature optimization to implement it as an incremental generator.
Mm-hmm.
But the option is out there.
Okay, thank you.
Thank you very much for this no signal I see, but we have
again camera overheating.
We have one question in the chat by Luke. You can take a look.
Yes, I guess
or I can transfer it to you. It's the same thing.
I can read it. So, is it possible to emit an absolute? Yes, it actually is. That's what I try to do in here. But you have to do it in steps. So, because what you can also do is instead of using a string builder and appending stuff, I can. So, where are we? Yep. Use the syntax factory. So in this case, I did something using static syntax factory. In this case, it's a C# syntax factory, but again, these are syntactic models and create a class declaration, add a modifier, and so on. And then at some point, I'm serializing that to a compilation unit. Or there were compilation units. Where do I do that? So it's compilation unit get text and serializing that. And if you're using Roslyn structures or DOM structures that are syntax trees, you can do that, but you have to then at some point convert it to C# or convert it to Visual Basic. But if you use these syntax factories or these abstractions that are provided by either the compiler or the .NET runtime, and then you use serialization functions to serialize them, basically as the last step of your generator, you could, for example, very easily implement generators that work both for Visual Basic and for C#. What I just found is that I spent way more time into looking into how I actually create a constructor and a parameter lists with types and modifiers to get the public keyword and the body statement and so on. For me, it was mentally easier to write these strings out, to be honest. But again, you can do everything in all different ways. I hope that answers the question.
Luke, feel free to, yeah, I think you can turn on your microphone and talk if you want. But if your answer is answered, your question is answered, yeah. Yes, thanks. Sorry, no microphone. Yeah, not a problem at all, of course.
Okay.
Yeah. Anything else? In any case, I don't see any other question right now, but can we reach you somehow? Twitter, LinkedIn, something, I don't know.
Yes, I'm reachable. I will put my Twitter handle in here, which is probably the easiest way to reach me.
Perfect. Yes. Thank you very much for this. Now, I think it's Gail's time, right? To talk about MetaLlama.
Yes, thank you.
And yeah, I will again switch off my camera. I think it's better for bandwidth. Just a reminder for the people that they are here right now. I am recording this and I plan to publish it to YouTube. So again, reach out and we'll find a solution if you don't like it. Yeah. Gail, again, the virtual state is yours now.
Thank you. I'll just share my screen. Need to figure out which one. It's going to be this one. Yes. Yeah. Thank you for this presentation of source generators. I guess my starting point is that, well, it's very useful and it's very complex too. We created a tool. Well, when I say we, I'm the lead developers on that tool, and we are a team of 3 developers. We have created a tool on the top of a couple of Roslyn extension points, and actually what it does, well, first it makes it easier to use this. That's the first thing, but the other is that it offers more things. So like this tool is MetaLlama, and like source generators, it tries to answer the problem of boilerplate elimination, but it actually does more. I'm not going to talk about the other things today because I just would like to wrap in 10 minutes, but it also allows you to do coded architecture validation, something you could do with the Roslyn analyzers, but it's much simpler with our framework. And you can also do live templates and code fixes also easily. But it's actually a bit different. So MetaLlama it's a high-level framework. If you have seen the code that like Martin has shown, like the low-level code, this is pretty complex because you are working directly with the level of abstraction of Roslyn that is very low. So, and MetaLlama is a layer on the top of that. So we integrate with these where is that, the code generators here, but also the analyzers, the suppressors, code fixing, code refactoring, which are all the extension points at Roslyn. But actually, this was not enough because we allow for something more. Remember that code generators can only add new syntax trees. It can only add new partial classes, but we need more. We allow to edit current source code. And for that, we actually had to create a fork of Roslyn, a pretty shallow fork, just one that adds an extension point that allows us to modify current methods, like user code methods. I don't want to say more. I want to show you MetaLlama in action. So let's switch to code, and I will show you so the idea, the principle of MetaLlama is that you create a template. So here, this is a template for logging. So we want to add logging to a method. So all the code that has a lighter background here, it is compile time code. And the normal code, it is a runtime code. So here we have a template for logging. And you see here is a field, method.target.method. This is a field, that's an expression that will be evaluated at compile time and actually replaced by the name of the target method. And meta.proceed, this is another kind of magic. It is replaced by the method that we are currently enhancing or transforming. So this is the template. The template is also a custom attribute. We name that an aspect. And then we are adding the aspect to the method. And the magic of MetaLlama is that when you execute this, you see that the template has been applied, that the method does more. So this is something new. You cannot do that just with code generators. With code generators, you can only create a partial class on the side. So you can also debug the code that is generated. And for this, you need to switch to a kind of magic build configuration that we call Llama debug. And when we do that, instead of seeing the source code, we will see the transformed code, the code that is actually getting executed. Okay, so now I do step into my method and I see this is the code that is actually being executed. So MetaLlama is this magic tool that changes your code. Now, if you don't want to debug, you want to see what's happening without building or debugging, you can go here, right click and do show MetaLlama diff, and you are going to see side by side your source code with the code that is executed. So this is the idea of MetaLlama, the template. In this example does not use code generators at all because it doesn't add anything. It doesn't add new members. But remember, with source generators, you can only add new members to partial classes. You cannot modify existing members. And MetaLlama solves that problem. So we can do a template for anything. Here is like an example to retry a method. Okay, so this is the same idea. We have a template, we have a for loop, a try catch, and we apply the template to the method. And you see the magic here. I say here I have 5 attempts, and here the 5 is here. Oh, this is it is pretty smart. The template can be complex. So far it was very simple. Here is an example where I want to do logging, but I want to generate an interpolated string that contains the method name, but also the parameter name, and unless the parameter is out, to add the parameter value. So this is how I build the string builder, the interpolated string builder, and then I'm just using that in the template. And now if I add this template to the method, you can see that I have created a nice interpolated string, and this time my logging is rich and meaningful. So 2 points. Like the first point here is that we can do things with MetaLlama that we cannot do with source generators, like edit existing methods. The second thing is that it's actually much simpler. You don't need to do many projects. You don't need to play with the Roslyn code model. It is pretty intuitive. So it's one layer of abstraction higher. So now let's see how we integrate with source generators. It's something that was not possible with the previous generation of our product. PostSharp itself, it was based on IL modification, as Martin mentioned. For the PostSharp, we're all based on IL transformation, so we could not do this. So the template is that. So this is a type aspect, so a custom attribute that you are going to add to a type, and we want to introduce a new property ID and initialize the ID to just a new GUID. So now if we do show MetaLlama diff, we see what's actually going to happen with the code. But the nice thing here is that we are integrating with source generators so that you can actually reference the new member inside your source code. You do not need to use weird cast and so on, as it was in PostSharp, or I guess in 42. And you will see that we have a source generator here, and this is the output of the source generator, because we integrate with that extension point of Roslyn. The compiler and the IDE actually sees the code that we want to add. And this is all like online real time. You can modify the code and see immediately what is the result. So that's all I wanted to show today, because in 10 minutes I cannot show much more. Now I wanted to show another to wrap it. I didn't want to show more feature, but just to wrap up.
We cannot hear you, Gail. You are muted. Can you hear me?
What happened?
Yes. Now you are unmuted.
I don't know what happened. So
Yeah.
maybe I touched the mute button by mistake.
Yeah.
So yeah, I wanted to show how these two things integrate, because when you want to integrate to add notify property change to a class, notify property changes becomes the main battle of meta programming, and I'm pretty sure we are winning this battle, because you need two things. You need to introduce new declarations into the class, and you need to modify the property setters to add the logic. Okay, so here is how we are adding property changed. Here we are adding on property changed, and here this is a template that overrides all property setters. How do we know which property setters should be overwritten? Well, here it's the build aspect method. It is the entry point of the aspect. I say that I want to implement this interface, and I say that for each property that it's actually writable, I want to override the accessor with this template. So this is how we do boilerplate suppression. You can see that the source code remains source code. This is very important, something that is often neglected. Your source code is your source code. The source code should be readable. You should not have to think very hard that there is a source generator. And these are implementation details here. The implementation of the property setter. This is an implementation detail. You don't need to see that in your source code. You don't need to be completely aware of that. Okay, ending now. The two things I did not show is that you can report warnings, you can validate code. I have other examples for that. So you can validate architecture thanks to that, and you can create code fixes. You can add like code fixes to your warning and so on. That would be for another 10-20 minutes of demo. Thank you. Questions?
Feel free. Anyone questions about
Yes.
this session, the previous session? Oh, sorry.
It's always me. Looks very impressive. I wonder, have you heard of quasi-quotation? It reminds me a little bit of this.
I didn't understand. Did I hear of what?
Quasi-quotation.
No.
Or let me write it in the chat. Maybe it's right. If I find the chat, it's here. It's okay. I hope there was a...
No, I didn't.
Maybe you look it up. It's somewhat similar. It's basically it comes originally from Lisp like languages, and it's a mechanism where you have code where you escape it, but inside the code you have unescapes, and then you can basically replace it, and it makes syntax editing very simple. I think in the .NET world, F# might have something similar. Might also be worth looking. It's not so much meant in. It's somewhat familiar, at least it looks somewhat similar or related to me. It might also be some differences, but might be worth looking up. Maybe there's something you can take over or go in other direction, whatever. So
thank you.
Yeah, just look up. But nevertheless, very impressive.
Yeah, thank you. Here the principle is that the template is still pure C#. So there is no exception to the language. Like you can use any C# editor. And we interpret which part of the syntax tree is build time or compile time according to just the status of the API. So for instance, the meta pseudo keyword is actually a static class, of course. While everything behind this is build time. So we know that this part is build time. We know that the iProperty interface is build time, but we know that value, it returns a dynamic. So value, the result is its runtime. So actually we build inferences on the syntax tree to determine which parts of the syntax tree are build time and runtime. That means that actually it sounds like we have an escaped language like Razor, for instance, but actually it's all based on inferences. That's how we do that. More questions?
Every time I see that, I imagine it's code that writes code that builds and ends up in a result. That's source generator and MetaLam. And I think it's a next level thinking, right? It's not about thinking what codes should I write to produce the solution wanted. It's what code should I write to produce code to produce at the end my solution. So I'm really into this. To be honest, I've never played around yet, but I'm really into this thing, and I wanna definitely spend some time learning more because it can remove so much of a boilerplate work that you need to do in every single project. At the end, you might have some library that does that for you.
Yeah.
So,
with PostSharp, so I've been working on metaprogramming professionally for 10 years, no more, 15 years professionally, and well, so we have a customer base with PostSharp, and we had some metrics, and we tried to estimate how many % that people save thanks to PostSharp. So if we look at the top quartile, so the top 25%, they save 15% in average. So it is not up to 15%. It's not even the average case, but like teams that use Bootstrap seriously, they save 15%. And so it is more like a statistical proof, or it's never a proof, but yeah. But some teams say they saved three digits of code, like, you know, that means like hundreds of thousands of lines of code. So
I could definitely believe that. I was thinking we live in a cloud there, right? Microservices and everything. And every time I'm going to a company, I sort of acquired the cloud transformation specialty throughout my career. And every time I'm going to a company and we start doing microservices, we are counting we have some problems of applying common logic to every microservice. So, for example, we want logging, right? Improve observability. That requires some actions that need to be done in every microservice using, for example, Serilog. I don't know, that will push all the logs to common repo. In order to do that, you need to write your library, but then you require some work from the actual developers of that microservice in order to everyone align in this observability, whatever solution you choose, ELK, for example. So I was wondering how this might help to actually create solutions or libraries that could help auto-integrate, let's say, all your solutions into all your microservices that we have around into following, one pattern of logging or one pattern for security. Authentication is a big thing, of course. What do you think?
Well, with Bootstrap, so the previous generation of this project, the IL-based, I created a logging library. So the current logging libraries that we have in .NET, they are optimized for manual logging. It now is getting better, but still it is not very good. So actually, well, I created a logging library, including the aspects that is specialized for like automated logging. So that's something I did because logging is quite universal. But actually, for many things, for instance, security, I don't know how much universal it can be. That means, can one third party vendor or open source project, can it implement the abstraction for the whole industry, or is it an abstraction that is specific to your company, your project? So for me, you need to think first, how large is the project? We are talking about like a couple of months for one person, or is it a project with 200 people for 10 years? So because then you can think what are going to be my economies of scale. So do I need to invest into developer productivity? Because it's always like so writing a source generator or an analyzer with the Roslyn API is very, very expensive and complex. But like, don't fool yourself, doing an aspect with Metalama is still a little complex. You still need to decide, I want to do that, and it's going to pay off or not. So so it's always a trade-off. So when there is a problem that we know that we can solve well for the whole industry, logging, notify property changed, to some extent multi-threading. So we do that and we invest months and months, and it takes 2 years to get stable. But this works and we have them. When it is specific to your project, you should think, will it pay off? How much do I need to invest into that? I think the most neglected thing, so the thing that you may overlook the more as an architect in your project is the validation of the code. Because it can be easy to realize, okay, like boilerplate code is something that I need to remove, and I see that directly, but it's also important to have automated code validation so that the patterns, like the practices that you want to be repeated to the whole team, you want this to be really respected. And you want this to be enforced in the editor and not during the code review. So this is something that is often neglected, but there are a lot of good tools to do that. Metalama is not the only one. You know, you have, well, of course, analyzers for code style. You can create your own code analyzers. You have SonarQube, I think, and depend tools. A lot of tooling that you can consider, and actually all these tools complete each other. So it's a big discussion.
Yeah, definitely. One last question for me is, what would be an ideal scenario for Metalama? I want to do this and this in my project, and this is a perfect fit.
Well, so are you asking about the perfect kind of application or the perfect use case?
Yeah. That I would really get some help.
Yeah. So now the biggest benefit from Metalama, or this is for it used to be called smart clients, WPF, or like the big things with many layers. There it is huge because these applications are complex. They have many layers. They are stateful. They are multi-threaded. So this is the biggest benefit. Now on the server side, you would use validation, logging, caching. And on the client side, you would use additionally notify property change, thread synchronization, dependency properties. Yeah, dependency properties are something that can be done, for instance, with source generators too.
I was about to ask the same question to Martin.
Yeah.
What would be an ideal case for someone to use source generators?
I mean, what I have been spending time with is trying to get rid of reflection calls in production, because what we're seeing now is the .NET team investing more and more time into ahead of time compilation. So I hope that we can get rid of most of runtime reflection and runtime emitting of code. The reasons being, we need to do ahead of time compilation for the code. Reflection is still not the fastest. I mean, if we compare it to things like Java, it's still a lot better. But now that we have things like cross-gen, where we basically generate the things that we need to run it, and it also works on the server, it's no longer an iOS problem. It's a thing, if we need to do with something with reflection, or we have dynamic code paths, it will make the implementation slower. So, for example, we have guarded devirtualization for virtual method calls with interfaces. So even dependency injection could be the next step that would remove reflection usage. So at least that's the hope that I have, where these things take us.
Yeah, I have an example with dependency injection in Metalama. But from my experience, performance is not so important for a majority of customers. I would say that developer productivity is more important for many customers. And like in the use case you have shown the, for instance, the logging method is a case where there is a big productivity gain.
Mm-hmm. Yeah, definitely.
Isn't the answer actually in the beginning of the first presentation? Basically, when you have lots of boilerplate code, and boilerplate code where the normal mechanisms like classes with methods don't help you to get rid of it, that's the point where you would consider using some kind of source code generator or MetaLlama. Isn't this already the answer? More or less?
Yes, if you say it's a developer productivity, then yes, because boilerplate code is basically developer productivity.
Yeah. Great. Seconds of pause just to think of more questions, I guess. First of all, and we still have time for questions. I will just start closing this event, and then, yeah, if you think of anything else, let it be. So, thank you, both of you. It was really, really nice. I'm really into this. As I said, write code to write code. I wanna definitely start playing with it. I didn't have the chance yet, but yeah, I will get into it. Gail, it was the second time I saw MetaLlama, and it's your. I already start thinking of I could use that there, and I could use that there. So I do think there is a lot of future in that. In any case, yeah, if there is no other question, it's been a very interesting meeting, this one, long also. I think someone is typing, so I will keep mumbling until the typing is over, and we can see if there is any question or a goodbye. Yeah, I don't know.
Yeah, thank you, George, for having me again.
I need to drop out. Bye, Mikael. Okay, I think we can all drop out. I think you can all do it. Thank you very much for this.
Thank you.
Thank you. Have a
Thank you,
nice
Mikael.
rest of the evening. Bye-bye.
Bye.
Thank you for the interaction.
Bye.
Ciao,
Bye.
everyone. Bye.